Welcome to Pre-Calculus 30. This is lesson number 2. So, section 1.2, we are going to be studying arithmetic series today. So, 1.1 we discovered we so lesson 1.1 we learned all about arithmetic sequences. Today we're going to see what the difference is between a sequence and a series. So, an arithmetic series, this is what a sequence would look like. Now, a sequence is just a sequence of numbers with a common difference between them. So this one would have a common difference of 3, this one would have a common difference of -4, this one would have a common difference of 1. Now, a series is the exact same thing as a sequence, except now we are finding the sums. So it would look like this. I will leave it to you to write the sums of the next two here and turn them into a series and fill in the rest of your chart. And then I want you to link the ideas, so just read it on page 24 of your textbook. So hit pause, give it a read, and then come back. Alright, so now that you're back, an arithmetic series therefore is a sum of terms that form an arithmetic sequence. So whatever our sequence is, we just take that sequence and we turn it into a sum by putting a plus sign in between every single term of the arithmetic sequence. The sum of the first n terms of a series is represented by S sub n. In the series, 2 plus 6 plus 10, etc., find each of the following: S sub 4 and S sub 7. Okay, so S sub 4 would mean we want to find the sum of the first 4 terms. So it would be 2 plus 6 plus 10 plus 14. So 14 and 10 is 24, plus 6 is 30, plus 2 is 32. So S sub 4 equals 32. Now S sub 7, we can just take and build on our S sub 4. S sub 7 is S sub 4 plus the next 3 terms after that. So plus 18, which gives us 50, plus 22, which gives us 72, plus 26, which gives us 98. So S sub 7 is 98. Okay, so this is a sequence, this is a series, and it's based on just a sequence that would be 2, 6, 10, without plus signs between them. I want you to read up on Gauss on page 22 in your textbook. He found a shortcut to add the numbers from 1 to 100. This was before the time of calculators, so it was actually quite an impressive feat that he was able to do it in minutes. And then try to answer this question: what do you think Gauss did next? See if you can figure it out on your own. Just a little challenge for you. Okay, we're going to use Gauss's method to derive a formula for the sum of a general arithmetic sequence. So this will work for any arithmetic sequence. So here we have the sum of any sequence of numbers: term 1, term 2, term 3, term 4, or not term 4, but onto the nth term. So what Gauss did, he wrote the series twice, once in ascending order and the other one in descending order, then he added them together. So let's consider the sequence 1, 2, 3, 4, 5. So this is a sequence. Now let's turn it into a series. We want to find the sum 1, 2, 3, 4 plus 5. Now this would be really easy for us to do very quickly in our head, but I just want to show you sort of a microcosm of Gauss's method here before we derive the general form of the equation. So he went 1 plus 2 plus So this is the sum S sub 5, so the sum of the first 5 terms. 1 plus 2 plus 3 plus 4 plus 5. Pretty simple. And we also have it S sub 5 in descending order. 5 plus 4 plus 3 plus 2 plus 1. Now let's add up these two rows and see what happens. S sub 5 plus S sub 5 is obviously 2S sub 5 because we're adding 1 to a second one. 1 plus 5 is 6. 2 plus 4 is 6. 3 plus 3 is 6. 4 plus 2 is 6. And 5 plus 1 is 12. Just kidding, obviously. So you notice the pattern here. We have the same number added repeatedly, okay? And this will give us 2 times the sum that we were looking for. So basically we can take 1, 2, 3, 4, 5, okay, which we know as n, the number of terms that we were finding the sum of in our sequence. Okay, so in our case, n equals 5. And our general expression, in this case, we could easily just write 6n, so 2 S sub 5 equals 6 times n, and n was 5. So 2 S sub 5 equals 30, and then divide both sides by 2, which means S sub 5 would equal 15. Okay, so that was simple. Let's see if we can verify that. So 1 plus 2 is 3, add 3 is 6, add 4 is 10, and add 5 is 15. Tomorrow in class we will discuss the general method that Gauss used to determine any sum and figure out how to derive the formulas that I'm about to show you. So we can use the formula S sub n, which is the sum of the first n terms, equals n divided by 2 multiplied by 2t1 plus n minus 1 times d, the common difference, where the sum of the first n terms is S sub n, the first term is t1, common difference is d, and the number of terms is n, and the nth term, I'm going to show you in a second, is tn. Now, from our arithmetic sequences lesson, we learned that in order to find the nth term, tn, in an arithmetic sequence, we could take term 1 and we could add n minus 1 times d. So tn is the same as t1 plus n minus 1 times d. Now you notice here we have 2t1 plus n minus 1 times d. 2t1 can be written as t1 plus t1. So t1 plus t1 plus n minus 1 times d. Now this can be written as tn. Okay, so we can simplify this equation if we have the necessary known information, and we can write S sub n equals n over 2 multiplied by t1 plus tn. And of course the nth term is tn. So here we'll do an example together. Male fireflies flash in various patterns, blah 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 blah. Suppose that under certain circumstances, a particular firefly flashes twice in the first minute, 4 times in the second minute, and 6 times in the third minute. If this pattern continues, what is the number of flashes in the 30th minute? So, twice in the first minute, 4 times, then 6 times. We can get a lot of information here right away. So term 1 is 2. That's the first minute. D is equal to the common difference. So we're jumping by 2 every time. So the common difference is 2. And we already have enough information to proceed here. So if the pattern continues, what is the number of flashes? So this is going to be Tn for the 30th minute. So we want to find the value of Tn when n is 30. Okay? So here are your n values for these following ones. First minute, second minute, third minute. We want to go all the way up to the 30th minute. Okay? So n is going to be 30. Now, the number of flashes in only the 30th minute will be determined by Tn. Okay, the number of flashes in the 30th minute. This is the arithmetic sequence, and we just want to find Tn. And we know that Tn can be found by taking T1 plus n minus 1 times d. So Tn equals 2 plus n minus 1 is 30 minus 1, which is 29, times d, the common difference, which is 2. Okay, 29 times 2 is 58. And we're going to add 2 to that to get 60. So in the 30th minute, the firefly will flash 60 times. Now, the next question is asking us, what is the total number of flashes in 30 minutes? So this is the sum of the flashes for the first 30 minutes combined. This is where we will use an arithmetic series. So we're going to add the sums of all of those first 30 terms together. So S sub n, and we know that we're looking for the sum in the first 30 minutes. So this is S sub 30. Now here's the nice thing. We already know T30, and that is equal to 60. So we can use the simplified version of our formula, which looks like n over 2 multiplied by T1 plus Tn. So in this case, it will be n is 30, we're looking for the 30th term, over 2 times T1, which is 2, plus T30, which is 60. All right, and then 30 divided by 2 is 15, and 60 plus 2 is 62. And get out your trusty calculator. 15 times 62 will give us 930 flashes altogether in the first 30 minutes. So S sub 30 equals 930 flashes.
There's an important meeting about to begin in the staff room. Very important meeting.
All right, so here's a your turn for you to go ahead and try. Looks fairly simple. Hit pause when you come back. The answer will be ready for you. So here's the answer. In the first 42 minutes, there will be 1,806 flashes. Okay, so the second example, now we're going to determine the terms of an arithmetic series. So the sum of the first two terms of an arithmetic series is 13, and the sum of the first four terms is 46. Determine the first 6 terms of the series and the sum of the first 6 terms of the series. So this is an interesting one because all we're given is 2 sums. We are not given any term values like Tn or T1. We're given 2 sums. So we are given S sub 2, which is 13, and we are given S sub 4, which is 46. We can get a little bit of information out of this though, because we know that 13 was found with the formula S sub 2 equals, now of course n is 2, S sub 2 equals 2 over 2 times term 1 plus n minus 1, and n again is 2, 2 minus 1 times d. Alright, so S sub 2 was found to be, this is just 1, so we're going to ignore it henceforth. T1 plus 2d, 2 minus 1 d, which is just d. Alright, so S sub 2 is found to be term 1 plus the difference. Makes sense, that's how we find all second terms, is we take the first term and we add the common difference. Let's look at S sub 4. S sub 4 would have been found as 4 over 2, n is 4, times T1 plus, now again n is 4, so 4 minus 1 times the common difference d. So S sub 4 would be 2 times T1 plus 4 minus 1 is 3 times d is 3d. S sub 4 would be 2T1 plus 6d. Now, we know the values of S sub 2 and S sub 4, so we can actually plug them in, and now we have two equations and two variables. So we can solve this system of equations. So this one was 46 equals 2T1 plus 6d. We can solve this system of equations by substituting one into the other one. I'm going to simplify this by dividing 2 out of every single one of these terms. So 23 equals T1 plus 3d. Okay. Now, how do we do this? Let's write an expression for T1 in general in this equation, and then substitute it into this equation. So solve for T1 and we get T1 equals 13 minus d. Now we can take that 13 minus d and we can replace T1 in this equation with it, 13 minus d plus 3d. Now you notice that we only have one variable because we've written everything in terms of d. The t disappeared, and now that we have one variable in one equation, we can solve it. So 23 equals 13 minus d plus 3d would be 13, so minus 1 plus 3 is plus 2d. Subtract 13 and we get 10 equals 2d, d equals 5. Alright, so we have an important number already. We have our d. Now we need to find what the value of T1 is. But now that we know d, we can take this d and replace in here to find our value of T1, which is 13 minus 5. And that gives us a T1 value of 8. So let's see what else we were asked to do. Determine the first 6 terms of the series. All right. So the first 6 terms of the series, we're going to start with this term, term 1, and we're going to add 5 to find every subsequent term after that. So 8 plus 5 is 13, plus 5 is 18, plus 5 is 23, plus 5 is 28, plus 5 is 33, 1, 2, 3, 4, 5, 6. So these are the first terms. Now, I've accidentally written this as a series because I put the plus signs in the middle. So as a sequence, it would just be 8, 13, 18, 23, and so on. All right, now we are asked to actually find the sum. So the sum of the first 6 terms, s sub 6, which is equal to 6 over 2 times t1, which is 8, plus n minus 1, which is 6 minus 1, times d, common difference, which is 5. And again, you can go back and check just to see that this formula is correct. 6 divided by 2 is 3. 8 right here. 6 minus 1 is 5. 5 times 5 is 25. There you go. So that's not an s. S sub 6 equals 3 times 33. And s sub 6 is the sum of the first 6 terms, which is 99. That's it for today's lesson. I will see you in class tomorrow.